Good afternoon, very patient Psych Assess students. I'd like to take the opportunity here to make a short video to respond to the first forum, which had the question, were the two statements true? One, that psych assessment can be harmful, and the other, that psych assessment can be beneficial. And of course, both are true. In the early history of psychological assessment, in particular, intelligence tests, IQ tests, so-called IQ tests, were misused because the standardized sample, the normative sample upon which the test was based, that you compared results to, was white middle-class socioeconomic status students. These tests were then used with black inner-city children who did not share the same culture as the white middle-class students who had much more opportunity. And so the results were sometimes used to say that black students were inferior, which is absolute nonsense. It was a total abuse of what turns out to be actually some quite sophisticated assessments. So harm was done, and unfortunately psych assessment got a bad reputation. Anytime that you do psych assessment, you're going to have to consider the beneficence, that everything you do has got to be to your client's advantage. And remember also that some things will stay with a student, particularly, or a client in their folder long after you've performed the assessment. So you're going to have some secondary audiences as well. So the answer to the question is yes, psych assessment can be detrimental if it is misused. And can it be beneficial? Yes, it can be beneficial in many ways. The objective tests are, many of them, quite well researched and can give you some good ideas about personality traits. You've had experience with the completely computerized PF-16, which quite frankly I think is just absolutely amazing. That report that you received is generated by a computer. Pretty good for a computer. Talk about artificial intelligence. So it is a useful test. I've used it with some of my clients. It's a great place to start conversations. If you're going to be doing any vocational counseling, it's an excellent tool there as well. That is an objective personality assessment that is completely computer capable. So you've had some, you could imagine what that could be like in starting a conversation with your client. So the PF-16 is really quite something. I'm very impressed by it. Now, so the answer to the question is yes, absolutely. Some of you have shared some things that you have had experience with regarding assessment, and thank you for sharing those. I have experienced assessment myself with my children, and many of you probably have as well. Some of the things that I've experienced have been quite beneficial in my case. I trust that it's the same for most of your experiences. At any rate, I'm looking outside my window at a dog walking around. Hold on. Okay, back in business. At least I think we're back in business. You've had an opportunity to examine 6 instruments and bullet point assignments with some rather straightforward research. There are some copies of those, some samples that you may borrow. You may use them for yourself if you'd like. Do not assess anyone else with them. Use them strictly for yourself. We have an obligation, by the way, to keep these out of the general circulation, and so, as I mentioned in an email sent out to you earlier, do not share them with anyone who is not a member of our class, and we don't want those. We have a responsibility to the publishers of those tests to keep them within the circle of the profession of well-being and our clients. Anyway, in Shannon Kidd's office, there is a file cabinet that has many of these assessments that you can borrow. In some cases, there's a manual. If you borrow a manual, just keep it for one day, or pass it on to someone else. Keep track of it, though, please. They are quite expensive. If you're able to take one or two of those assessments for yourself, that would be a good way for you to become familiar with them. You're going to have to choose some assessments to use in your upcoming mock psychological assessment. I posted some things to the resource page today about that, and also put a video in there for you as well. The second forum post has to do with the normative distribution. Fancy word for it is also called Gaussian distribution, Gaucian distribution. And someday, if you're on Who Wants to Be a Millionaire and they ask you what's another name for the normal distribution, and you say Gaussian distribution because you heard it from Dr. John, please remember me if you make it all the way to $1 million. Okay, light side, of course. I would like to just present a couple of things about the normal curve for you. Some very, very straightforward ideas that don't require much of an understanding of math. There's an awful lot of information that you can get from the normal curve. The normal curve, first of all, to assume normality of a distribution, you're going to have a minimum of 16 data points. Better to have more than that, but minimum of 16 to assume normality. Most distributions are normal. Some are skewed one way or the other, but distributions of many human traits are normally distributed, and the curve is a normal distribution. Here's some things that we can exploit about the Gaussian distribution. So let me see if I can get this thing so we can have it. It looks pretty good there. Okay, first of all, Gaussian distribution. Fancy word for the normal curve, and as many of you have stated, it is the bell curve. The mean is in the center. These scores are fall below the mean. These scores are above the mean. This is frequency of scores. Frequency of scores. In other words, how many scores fall at each of the points here. And this is the actual score. So most oh my goodness, it looks backwards. I'm going to have to reverse this video, huh? Well, we'll figure it out. Or maybe it's just backwards from my viewpoint. Maybe I should hold this in a mirror for you. Sorry. Anyway, normal distribution has the mean right in the center. The mean is usually expressed with x bar. Or if you're looking at a sample, it would be expressed as mu, lowercase mu, like a cat, mu. Symbol for the mean of a sample, x bar, symbol for the mean of a population. Now, if this represents the scores of 1,000 people on one of the larger intelligence tests, the mean, most of the scores are going to be centered at the mean here. And as you get above the mean, the number, as you get above the mean, higher the mean, the scores become less and less and less and less and less the farther out you go. And the same thing as when you go below the mean. So most of the scores fall close to the mean within what is called a 1 standard deviation above and 1 standard deviation below. The Gaussian distribution is mathematically constructed so that approximately 34% of the data falls between the mean and one standard deviation above, and 34% falls between the mean and one standard deviation below. It's actually 34 point something or other, but 34 is close enough. So 68% of the total scores will fall between one standard deviation below and one standard deviation above. If we go out to 2 standard deviations plus 2 standard deviations, or minus 2 standard deviations, we have a much smaller percentage of scores beyond here and below here. I believe at 2 standard deviations we are looking at 95% of all scores between one standard deviation above and one standard deviation below. Now, many tests are normed so that the mean is 100 and the standard deviation, so it would be x bar equals 100, and the standard deviation, which is often lowercase sigma, is often 10. So supposing we have someone whose score was 120. We know that that is 2 standard deviations above the mean. Here's 100, 1 standard deviation, 110, 2 standard deviations, 120 right here. They have scored higher than 97.5% of everyone who's taken the test. Now, why is that? We have 95% of the data from -2 to +2. That leaves 5% of the data half here and half here. So over here we have above 2 standard deviations just 2.5% of the data, and beyond, and on the lower end, the negative scale, we have another 2.5% of the data below it. So if you have someone who scored a 120, you know right away that they have scored better than all of the people over here. That's 97.5. Let's make sure I've got that correct. 100 minus 2.5. 0, 5 from 10 is 5, 2 from 9 is 7, 9, 97.5. So someone who scores 120, that's 2 standard deviations above the mean, that's quite a rare score. They have scored higher than 97.5% of the people who have taken the test, or the people in the normative group. I would like you to understand this very basic concept of how we can exploit the characteristics of the Gaussian distribution. If a person scored 1 standard deviation above the mean, then they would have scored higher than all of the people on this side, and that would be 84%, I believe. It's actually probably 84 point something percent, but they would have scored higher than 84%. And the same token, supposing you get somebody who has a raw score of 2 standard deviations below, that would be 90 here and then 80 here. So if someone scored an 80, that would be 2 standard deviations below. 97.5% of the people scored higher, and only 2.5% of the people scored lower. So that would be quite actually a rare score on the negative side, and at 120, 2 standard deviations above, would be quite quite a rare score on the positive side. I hope this helps a little bit with the question that you've responded to in the forum. There's not a lot of mathematics involved in this course, but you should know that we can exploit the characteristics of the Gaussian distribution to be able to give a percentage of scores above or below any score that falls in the distribution, as long as it's normally distributed. I hope that helps somewhat. Remember the term Gaussian distribution. X bar represents the mean of a population. Lowercase sigma is the standard deviation. Now, standard scores are scores wherein they take this Gaussian distribution and overlay it onto another set of scores. T-scores are standard deviation that has a mean of 50 and a standard deviation of 10. So with T-scores, you know right away, if someone scored higher than 50, they scored above the mean. Lower than 50, you know they scored below the mean. And you can get an idea about what percentage of people they scored higher or lower than. There are other kinds of standardized scores as well. Z-scores, you'll learn more about those in research methods. It's not really very complicated mathematics. Remember this term, Gaussian distribution. Hope this helps you out, and I hope it isn't reversed on your screen. I'll have to watch the video and figure it out. So, guys, hang in there. If you have any questions, just go ahead and email me. And remember, I'm on campus on Wednesdays before I teach at 6:15. So if you're on campus on Wednesday, stop by and see me. I'm usually in the community hall if it's free. If not, I'm in room 123. So, guys, take care.